If it has two congruent sides, what kind of triangle is that? All right, this triangle is an isosceles triangle. Isosceles triangle. Not all triangles have these features, so this type of triangle is very special. Take a look. Okay, so if it's an isosceles triangle, you learned about isosceles triangles with Mr. Miller. If these sides are equal, what do you know about their opposite angles? They're also angles. It's called the base angle theorem. They're also equal. Well, if this is 90 degrees here, and these two are equal, they have to measure what? 45. Okay? These are things that you have to remember while you're doing this section. Isosceles triangles, their opposite angles are equal. Let's study these and we'll find out what's really special about a 45, 45, 90 triangle. So, looking at this picture, if you know this is 2, what other part of this triangle do you know is 2? Right. That makes them isosceles, which consequently makes these angles congruent to each other, which makes them have to be 45 degrees, because the 3 have to add up to 180. Now, I need to find this side right here. Yes, it's a right triangle. This is the hypotenuse. I can use the Pythagorean theorem. So that's what I'm going to do. A squared plus B squared equals C squared. A and B are the legs. What's 2 squared? So 4 plus 4 is 8. Take the square root of both sides. But we're not using decimals. That's what the first section was about. So this is going to equal the square root of 8, and I need it in simplified form. So what factor of 8 is a perfect square? 4. So I can rewrite this as the square root of 4 times the square root of 2. And that allows me to simplify this part to 2. Okay? So I'm going to write up here 2 times the square root of 2. That's how long that side is. And bear with me, we're going to do one more, and then I think you'll see what's special. First of all, what do you notice here? Perhaps. Okay, let's keep that in mind. So this is 5, therefore this is 5. Because they're isosceles. It told me they were isosceles. That means that this has to be 45 and this has to be 45. If I need to find C, I'm going to do the same process. I'm going to use the Pythagorean theorem, and let's see what happens. A squared plus B squared equals C squared. 5 squared plus 5 squared equals C squared. What is 5 squared? So what's 25 plus 25? 50? 50? Okay, I'm going to take the square root of both sides. However, I do not want just this. I want the simplified form of that. Does 50 have a perfect square factor? 25. So I can write it like this. And what's the square root of 25? Oh. If I write this up here, and I study those two, do you notice anything? You told me this and this and this. Do you see that? This and this and this. What's happening to the hypotenuse in both of those? What?
They're the same number as square root by 2.
Multiplied by the what? Square root of 2. They're the same as the leg multiplied by the square root of 2. That is true for all 45, 45, 90 triangles. So consequently, we don't have to do any work for this. We can get all 3 sides because we were told it was isosceles. I know that's 8. This has to be 45. This has to be 45. And this has to be what? 8 times the square root of 2. It will happen every single time. Super easy, right? So far. Let's turn the page and write down what that theorem is. It's the 45, 45, 90 triangle theorem. Basically what it says is, in any 45, 45, 90 triangle, the hypotenuse will be equal to the leg times the square root of 2. In any 45, 45, 90 triangle. Cool? I'm going to underline this and point right to that. Always. How about if I write always here? All right, these look like a whole lot of work, but they're really not. We're just going to pick apart what we can in this. Problems. Find the measures of the angles, legs, and hypotenuse in each triangle below. All right, so let's look at this picture and what you learned. This is a 90, and these are congruent, so these have to be how much? 45, so I'm just going to write it in there. Therefore, if they're 45, 45, 90, and the legs are 6, how long is the hypotenuse? 6 times the square root of 2. Boom. Yeah? Okay, we're going to skip that second one for now. We're going to go to this picture. This is telling me 45, 45, 90. That means that these sides have to be congruent. Therefore, this leg has to be how long? M. And the hypotenuse has to be what? M times the square root of 2. Cool? All right, let's see what else we can do. Here. This one is a 45, 45, 90 triangle. That means that these sides are congruent. I know that. I also know that in a 45 by 45, or 45, 45, 90 triangle, the hypotenuse is equal to the leg times the square root of 2. Oh, if this is the hypotenuse, how long is the leg? 7. You see it? It's right there in front of you. The leg has to be 7. Yeah, yeah? 7 and 7. Okay, the same with this. You know that this is a right. These are congruent, so they have to be 45. The hypotenuse is 20 times the square root of 2. Therefore, the legs must be what number? Come on.
20.
20. All right. Let's do this one. Here, it tells me it's isosceles. Therefore, these angles have to be 45 and 45. They have to be equal. They have to add up to 180, and they have to be equal. Okay. The only thing I know here for sure is that the hypotenuse is equal to the leg times the square root of 2. Correct? I don't know what my legs are. I'm going to make them x. Let's plug in what I do know. I know my hypotenuse is m. My leg is x times the square root of 2. If I want to know what x is, what do I have to do? If I got to get x by itself, what do I have to do? Divide by the square root of 2. Oh, how long are my legs? They're m times the square root, they're equal to m over the square root of 2. M divided by the square root of 2. So you just got to use this equation in any way you can to help you figure out what they are. How about this one? 45, 45, 90, these two are congruent. Hypotenuse equals leg times the square root of 2. The hypotenuse is 17. I don't know my leg, but I know it's times the square root of 2. So then what do I do? Divide by the square root of 2. My legs are equal to 17 divided by the square root of 2. We're going to skip over to this one. This tells me this is 45, this is 45. It's like a puzzle. You just have to look at it a little bit. If this is the square root of 14, what's this? That means my hypotenuse, which is right here, has to be the square root of 14 times the square root of 2. Correct? Leg times the square root of 2. Oh, but we can't leave it like that. That wouldn't be any fun. We can't do anything with this, but we can put them together like we did yesterday. And now we have to simplify. Does 28 have a factor that's a perfect square? 4. So I got to write it as the square root of 4 times the square root of 7. And that helps me take the square root of 4, which is 2. And that is my hypotenuse there, 2 times the square root of 7. Okay, let's turn it over. We're almost done. Doesn't take too long now. These are the same on the bottom there. Just double copied somehow. All right. You need to find x and or y by looking at the picture. So take a look. If this is 70, what's this? Okay, so now I'm just going to look at one of these triangles. If these sides are congruent, that means that these opposite angles have to be equal, which makes them have to be 45. If these are congruent, it's an isosceles triangle. These have to be 45. Oh, if these are 70 and this is the hypotenuse, then how long is my x? 70 times the square root of 2. If it's a 45, 45, 90 triangle, it's 70 times the square root of 2. Boom. You get it? I know, it's so hot in here. I had to have the window open. It's so hot. All right, here. Again. I have to find the leg. I know from this drawing that this is an isosceles triangle. That means this has to be 45 and this has to be 45. The hypotenuse is 11 times the square root of 2. So the leg must be what number? 11. The leg has to be 11. Because the hypotenuse is 11 times the square root of 2. Almost done. You have to look at this as a big isosceles triangle. That's what this means. So this is 9 times the square root of 2. I already have y. If this is a big isosceles triangle, that means that that and that have to be congruent. So that's 45 and that's 45. Then I'm just going to look at one of these. If this is 90, this is 45, this has to be 45. I've shown it's a 45, 45, 90 triangle. This is the hypotenuse, therefore the leg must be what number? 9 and 9. Got it? Almost done. Okay. If this is 90, this is 90. If that's 45, this is 45. If that's 45, that cut that 90 in half, so that's 45. So I've proven what they gave me. I have two 45, 45, 90 triangles. In this triangle, the leg is 5. So what's x? 5. What's y? If this is 5, what's y? See? And then this is the same because they're isosceles. Not so bad. That's it.